Enkephalin, the brain's natural pain relief system. Pain is not just a physical sensation. It is also an emotional experience, and it is carefully regulated by the brain. One of the most important systems involved in this regulation is a group of natural chemicals called enkephalins. Enkephalins are part of the brain's own pain control system. They reduce pain, they calm stress responses, and they help regulate emotion and motivation. Enkephalins belong to a larger family of chemicals called endogenous opioids. Endogenous means they are produced naturally by the body. Opioids are substances that reduce pain and produce calming or rewarding effects. Unlike drugs such as morphine or heroin, enkephalins are made by the brain itself. They are the brain's internal version of opioid painkillers. Enkephalins were discovered in the 1970s. In 1975, scientists John Hughes and Hans Kosterlitz identified the first enkephalins. This discovery was revolutionary. It showed that the brain produces its own opioid substances. Pain relief did not come only from drugs. It was built into the nervous system. The name enkephalin comes from Greek. It roughly means in the head. This reflects where these chemicals were first identified and where they have powerful effects. Two main types were discovered: met-enkephalin and leu-enkephalin. They differ slightly in structure, but have similar effects. Enkephalins are neuropeptides. This means they are larger and slower acting than classic neurotransmitters like glutamate or dopamine. Rather than sending fast, precise signals, they modulate activity over longer periods. Their role is regulation, not rapid communication. Enkephalins work by binding to opioid receptors in the brain and spinal cord. The main receptors involved are mu and delta opioid receptors. When enkephalins bind to these receptors, they reduce neural activity. This has several effects. Pain signals are dampened, stress responses are reduced, emotional reactivity is softened. One of the most important roles of enkephalins is pain modulation. They are heavily involved in the brain's descending pain control system. This system allows the brain to reduce pain signals traveling up the spinal cord. Pain is not simply blocked at the source. It is actively regulated by the brain. Enkephalins play a central role in this process. This helps explain why pain can change depending on context. During emergencies, people may feel little pain at first. During stress or fear, pain can be temporarily suppressed. Enkephalins are part of this adaptive response. They allow action to continue when pain would otherwise be overwhelming. Enkephalins are also released during exercise. This contributes to the phenomenon often called the runner's high. During prolonged physical activity, endorphins and enkephalins increase. This can reduce pain and create feelings of calm or mild euphoria. It is one reason exercise can improve mood and reduce discomfort. Beyond pain, enkephalins also influence emotion. They are active in brain regions involved in stress and anxiety. These include the amygdala, hypothalamus, and limbic system. By dampening neural activity, enkephalins can reduce emotional intensity. They help prevent stress responses from becoming excessive. This makes enkephalins important for emotional regulation. They do not eliminate negative emotions, but they reduce their intensity. They help the brain cope. This buffering role is especially important during prolonged stress. Enkephalins also interact with reward systems. They influence dopamine pathways indirectly. This means they can affect motivation and pleasure. However, their effects are subtler than drugs. They provide balance rather than strong reward signals. This helps explain why natural rewards feel calming rather than overwhelming. Clinically, enkephalins are extremely important. They help explain how painkillers work. Drugs like morphine and heroin mimic enkephalins by binding to the same receptors. But these drugs are much stronger. They overstimulate the system. This leads to tolerance and addiction. Enkephalins, by contrast, are tightly regulated. Chronic pain conditions may involve altered enkephalin signaling. If enkephalin release is reduced, pain may become harder to control. The belief that treatment will help can activate real biological pain control systems. This shows that expectation and biology interact. Here are some everyday examples of enkephalins at work. First, when pain feels less intense during an emergency, enkephalins are helping suppress pain signals. Second, after sustained exercise, enkephalins contribute to reduced discomfort and calm mood. The mechanism. Fifth, when the body naturally recovers from pain, enkephalins help restore balance. There are several interesting facts about enkephalins. They are released both in the brain and spinal cord. They act locally and regionally, rather than globally. They are broken down quickly after release. This prevents excessive opioid activity. Their short lifespan helps maintain balance. Enkephalins highlight an important principle. Organisms that could suppress pain temporarily had better chances of survival. They could escape danger. They could continue functioning. Once safe, pain could return to promote healing. Enkephalins support this flexible response. So, what is the big picture? Enkephalins are not pleasure chemicals. They are not reward chemicals. They are balance chemicals. They reduce pain. They soften stress. They help the brain cope with challenge. They work quietly and efficiently. They are released when needed. They shut down when no longer required. This makes them ideal for regulation rather than stimulation. Understanding enkephalins helps explain pain relief, stress resilience, placebo effects, and addiction. It shows that the brain has powerful tools for managing discomfort and emotional strain. And it reminds us that relief does not always come from outside. Much of it is generated within. So the next time pain fades faster than expected, or stress feels more manageable than you thought it would, remember this: your brain has its own pharmacy, and enkephalins are one of its most important medicines.
If you enjoyed our channel, please click subscribe.